Hey guys, this is Miss Swift. I'm really excited for y'all to learn about the comparisons between the area formulas for squares and rectangles, and then being able to see how the formula of those connect to the area of triangles. Good morning, class. For today's activity, we will be engaging in the use of Sketchpad. Each of you will be given your own example to work with. On the very first page, there is either a rectangle or square depending on your personal example you're given. You will be asked to find the area of your shape. Page of your Sketchpad document that's labeled triangle, you will be asked to find the area of the triangle that is inscribed this square. This square is the same as the previous square that you were given on the first tab. You may find the area of these shapes any way you would like. Just be sure to be able to justify and explain your reasoning and work when the discussion period comes at the end of class. My name is Super Sarah, and to find the area of the square I was given, I counted the distance from one point to the other to find the length of one side. Then I took that side and multiplied it by itself, or squared it, to find the area of the entire square. So I multiplied 6 times 6 to give me 36. Area of the triangle. I knew the formula was base times height divided by 2. The base of the triangle was the same as the top side of the square, so it was 6, and the distance from the base to the vertex of the triangle, or the height, was 6 as well. I then multiplied 6 times 6 to give me 36 divided by 2 to give me the area of 18. My name is Mighty Meredith. I was given a rectangle to find the area of. I found the area by counting each individual block inside of my rectangle. This ended up being 72 blocks total, so that the area of my rectangle was 72 units squared. Area of the triangle inside of the rectangle, I attempted to count all the squares inside of the marked triangle. When I did this, I got about 35 squares total, but it got a little tricky when the hypotenuse of the triangle split some of the squares into unequal pieces, so I kinda had to guess. My name is Fierce Felix, and I was given a square to find the area of. To do so, I found the difference between 2 points on one of the sides. 18 minus 6 gave me 12 units. I then knew the area of a square is base times height, or side squared, so I did 12 times 12 to give me 144 units squared for the area. Next, I was to find the area of a triangle. I knew the formula was base times height divided by 2. The base and the height of the triangle were both equal to sides of the square. So I ended up doing 12 times 12, getting the product of 144, dividing it by 2 to get 72. Now if everyone can look up at the smartboard, I will have each individual's document pulled up so we can discuss. Let's start with you, Super Sarah. You explained that you counted up to get the lengths of the sides of the square. You ended up with an area of 36 units squared, which is correct. Can you think of another time when counting to find the lengths of a square wouldn't work, and what exactly you would do? Well, I'm not exactly sure, but if I didn't have the graph to go off of, then I wouldn't have known how to count up by it. So I guess if the square was not on a graph, I would actually have to find the distance or measure the length, maybe with a ruler or using the distance formula. Great thinking, Super Sarah. Now, Mighty Meredith. You said you were able to find the area of a rectangle by counting the amount of squares inside of it, which worked out for you. But when you tried to count the amount of squares inside the triangle, however, you said you had some trouble. Can you think of a way you could have done this differently? I suppose when it comes to the triangle, that the best solution would have been to use the actual triangle formula because of the line of the hypotenuse that causes some of the squares to kind of be off when you're adding them up. So if I would have done base times height divided by 2, I would have got 36, which was close to 35, but not exactly accurate. Correct, Mighty Meredith. Many students make the same mistake when finding the area of triangles inside of squares or rectangles, assuming they can just count. As for Fierce Felix, your explanations of using the formulas for each shape and noticing that the base and height of the square or rectangle is in fact the same of the triangle inside of them were great. Great job today, you guys. In conclusion of what I wanted y'all to take away from today was how easily errors can be made when finding the area of shapes. Counting doesn't always work, but the formulas will. Also that you can find any area of a triangle with the dimensions of the surrounding square because they share the same base and height.
Created using Powtoon.